Hey everyone, it is time to start the real chemistry course, the chemistry course taught at UT Austin called Chem 301. We're going to be working in Unit 1, which has a very fancy name. It involves quantum mechanics and atoms and periodicity, that sort of thing. But I like to think of it very simply as this. This is the unit in which you learn where the electrons are around the nucleus. Because it turns out, once you figure out where the electrons are around the nucleus, then you can figure out in Unit 2 whether or not they overlap with each other to form bonds. So we're going to spend a lot of time in this particular unit doing things like carving out our own versions of where the electrons are. That, by the way, was a p orbit that the electrons were found in. Now, your initial impression of all of this might be to be kind of scary because there's going to appear to be a lot of math at first, because I have to show you that this all comes from this subject called quantum mechanics, which is heavy-duty differential equations, which nobody does until they're a whole lot older. But here's the funny thing about all of this. Absolutely everything that I'm going to want you to take away from Unit 1 with is found in the periodic table. That's what's amazing about it. That periodic table is so chock full of different kinds of information that you can use it to pretty much solve everything from Units 1 and 2 in terms of the kinds of questions we might ask. You might ask then, well, why does this seem so hard? And initially I would say it's because if you were taking simply a high school chemistry course, our expectation wouldn't necessarily be that you understand the origin of what's on the periodic table. We just tell you to go memorize the periodic table. But this is a college course, which means then we have to explain why the periodic table came to be. Have no fears though, because as we take this on, we're going to systematically approach it in a way that really will turn out to be quite manageable for you. And in fact, when it's time for us to ask you questions on the exam, we'll show you all of the review materials and even more to help you be able to get ready so that you'll be confident when you walk in to take the test. So let's go ahead and take a look through sharing on the screen here, the home page. So here it is. Here's the home page of the course. And we're now moving into this section called Unit 1, Quantum Mechanics, Atoms and Periodicity. As I said, this is what I like to call where the electrons are. Notice that this is in two parts here. There is a first half and a second half to learning about this material. The first half is going to be more about how the periodic table came to be constructed. That's the atoms part. And then the second part of it has to do more with why it's called the periodic table, what the periodic trends are that you see in it. So let's go ahead and take a look here at what's coming up. As one would expect, you have a variety of learning modules, and I'm going to come back to these in just a moment. But what I'm going to hop down to right now is to the assessment page, not because we're going to talk about the assessments right now, but because I want to show you that just like with Unit 0, there are 20 questions in Unit 1. And those 20 questions in Unit 1 are broken into two parts. So the first half of it on Exam 1 will be the ones that you see here in green. They start with a discussion of electromagnetic radiation, and they run through you being able to create the electronic configurations for the species. The next unit, I'm not going to click to it, but when we do click on it, it's going to turn out to be highlighted down here to include a lot of these questions down here that have to be that are about ranking the trends on the periodic table and the different theories about the periodicity on the periodic table. So those are the parts of it. There's the first half of Unit 1, which is understanding the origin of the periodic table, and the second half, which is looking at the periodic trends on that table. Now, I'm not going to go through each of the different sections talking about them in any great detail right now. But I can show you as we take a look at this that a lot of this is going to be familiar to you in that you've already seen these sorts of things. Here's the learning modules that are coming up. The first one is about early pioneers who figured out that the atom isn't just a hard sphere. We learn about the use of light to be able to understand what's taking place in the atom. Then we look at a couple of different ways of describing what's happening in the atom. One of them is using classical mechanics, kind of like Newton told us about, where everything has a mass and it has a momentum and you can follow those trajectories. And this is where we're going to find out that when particles get really small, they stop behaving that way. And we can no longer talk about them in terms of the fact that they're moving 11 miles per hour down I-35 or something like that. So then we have to move to a new way to think about how you do your learning. And that's where we start talking about quantum mechanics as a way to figure out where the electrons are. And in fact, after an introduction to quantum mechanics for explaining the energy levels in the hydrogen atom, we talk about it in terms of all of the atoms on the periodic table. Now, I'm going to go ahead and move on over to the periodic table to show you what we were talking about before. Here's our periodic table, nice and colorful here. There are so many interesting pieces of information on here which are important to you. We learned that there are, in fact, quantum numbers to be dealt with. And those quantum numbers can actually be described here on the periodic table. As I go down it, there's n equals 1, 2, 3, 4, 5, and so on as I go down the periodic table. And that tells us that our atoms are getting bigger and the electrons are getting farther away from the nucleus. Then I'm able to break it up into different parts. Over here on the far left, there are these two groups right here, which are the s orbits, which are spherical. Over here on the right are the p orbits, which were the ones that were shaped like two bowling pins kissing or something like that. You have your d orbits here and your f orbits down there. You can break it down even more to the point where you're talking about individual orbits. Those individual orbits have at most 2 electrons sitting in them, one of them which is spinning going up and one of them is spinning going down. And all of that's sitting right here on the periodic table for you to be able to pull out. You might think, oh my gosh, how am I going to be able to do this if I don't have a periodic table? And the answer is you will always have a periodic table. You always have the periodic table available to you whenever you take any kind of test in this course. Now, the most important thing that you're going to come away with here is which of the electrons turn out to be the reactive electrons in the periodic table. So all that work with quantum mechanics to get to the point where when we're all done with it, we know, for example, that lithium has a single electron, which is its valence electron, and that's the one that does all of its reacting for it. On the other hand, fluorine over here has 7 valence electrons, and those are the ones that do their reaction. And as we'll be learning when we get to Unit 2, they end up combining with each other to make ionic or covalent bonds. But I can tell you right off the bat, just looking at this table, that right there, oxygen has got 6 valence electrons. Magnesium's got 2 valence electrons. So that's the takeaway message that we have. When we move on to the second half of Unit 1, that's where we start talking about the periods that we have here and the trends that take place across these periods. It turns out, for example, that over here on the left-hand side are where our metals are found. And over here on the right-hand side is where our non-metals are found. And there's this nice sort of divide right here in blue there, which is the metalloids, the things that are involved in semiconductors that sort of separate them from each other. And there are trends on here that we know about. We know that as we go down the periodic table, things are going to be getting heavier and heavier. And as a consequence of that, we know they're getting larger and larger. They're going to become less easy to be able to explain because of the number of electrons there are. We're going to be able to talk about things like as we go from the left side of the periodic table to the right side of the periodic table, interestingly, they get smaller in size. That's an odd thing to think. We also will learn that as we go from the left side of the periodic table to the right side of the periodic table, that there's a greater interest in electrons. So for example, fluorine loves itself some electrons, lithium not so much, and that's why when it's all over, lithium ends up giving an electron up and fluorine ends up taking that electron on. Those are the ideas that we're going to talk about in Unit 1. And all of them come to bear in deciding to put together a periodic table like this, which pretty much, having it available to us, allows us to ask almost every question that's being asked about the Unit 1 material. Best of luck with this. We will be back to talk about how to take an exam in Unit 1 in a couple of weeks.